Hey guys, here we are, Chapter 16, Section 7, Hydropower, getting electricity from water. Once again, all renewable sources of energy, the water cycle keeps doing its thing, the water comes back and back and back. So, great source to get it. So where do we get our hydroelectric energy from? Water flowing over dams. This is one we typically think of, and it's probably the most common, if you will. We build the dam, and then we allow the water to flow over the dam. The water coming down spins our turbines. We get our electricity. We can also get it from tidal flows, like estuaries or coastal bays, where the tide comes in, so then the river moves this way, and then the tide goes out. So we can set up a turbine in these waterway systems. As the water comes up and back, once again, it's spinning the turbine. Doesn't matter which way the turbine spins, we can generate electricity. And then also from ocean waves. The waves themselves, as they come in and push, this can turn it as well. So 3 different ways that we get it. Some of the downsides, we do have some environmental concerns. Once again, if we build a dam, we're changing up ecosystems, disrupting water flow, lots of various things. And when it comes to hydropower, there are limited availability of suitable sites. It can't work everywhere. Not everywhere has fast-moving water, or do we have the conditions right to kind of make it work in the ocean, if you will. So let's go ahead and take a look at some of these approaches. So hydropower in general, right, uses the kinetic energy of moving water. Now, once again, this is an indirect form of solar energy, right? It's the water cycle. The water evaporates, rises, condenses, precipitates, falls, gravity doing its thing, and we get falling, flowing, moving water. So once again, in a real sense, just like solar and wind, hydro is indirectly another form of solar power. This is the world's leading renewable energy source. It's indirect, just make sure we tie all of this in. Who's using hydropower? Well, lots of countries are, but the top 3 producers, China, Brazil, and the United States. China, massive amounts of people, but also they have very mountainous, hilly regions, which works really well for hydropower because we get good falling water. Brazil, Amazon basin there, they have a lot of moving water as well. And then the US, especially our west coast. Higher mountains out there and tends to work better for our hydropower. And in the United States, hydropower supplies 50% of the electricity that's used on the West Coast. So it's a huge factor involved in the United States energy and especially our West Coast. Now the Tennessee Power Authority, the Tennessee River, we have them on the East Coast, but more predominant in the West Coast. Now let's talk about trade-offs that we have with it in general. Now, largely we're talking about dams at this point. We're going to talk about a couple of others here in a minute. It does have a high net energy. Once the dam is built, high net energy. That's a lot of water and it flows 24/7. By building the dam, we can control the flow. By controlling the flow, we control how much electricity we produce. Faster flow, more electricity, and we can even bring more turbines online or turn some turbines off. So we can control the flow, control the amount of energy, high net energy. It's a large untapped potential. We still have areas that we could build more dams, we could pull in more power from it. And some of the dams we have, we could tie in more turbines to generate more electricity. We're back to that smart grid. If we have a smart grid, we can distribute the power around the country more effectively. Low cost for our electricity in this, once again, the build is expensive, but once it's built, the electricity then winds up being very cheap. Very low emissions of CO2 and any other air pollutants, especially if we're talking in the temperate areas. If you're in a tropical environment, a little bit different, but temperate, which the United States, most of China is in, very, very low CO2 or any other greenhouse gases. Disadvantages. Well, there's a large land disturbance, right? We build the dam, we turn a river system into a lake system behind it, and also we're disrupting the water flow on down. A lot of times this affects wetlands, estuaries, things of this nature. If it's in a tropical reservoir, tropical areas, we get very high methane emissions because there's rapid biomass decay. So in tropical areas where you build it up, warm water, we do wind up generating a lot of methane, once again, just from things dying, rotting quicker because all of the water in the wet area. And obviously it's going to disrupt the downstream aquatic ecosystems. We're disrupting the ecosystem behind it because it's going from a river to a lake. Not everything can adjust to that as well. And then obviously the streams below it are not getting as much water as they once used to. So, by and large, we're looking at dams in that scenario. Other ways that we get hydroelectric from flowing water. Now, a lot of these are going to be coastal bays and estuary. The tide comes in and the tide comes out, right? It's doing this every 6-7 hours. Comes in, comes out, comes in. This constant movement of water. Now, this really isn't the water cycle. This is the gravity of the moon pulling the water, but we can still take advantages because we get the flow of water. Another one is using tidal energy dams. So what we do is we have a bay. I'll put a picture up here to show it, but you have a bay and the water fills up at high tide. Well, if you build a dam across the bay with a gap in it, or a gate, if you will. Well, you open the gate and you let the water flow in to high tide, and then you time it and you drop the gate and you dam the water. So now the tide goes out, but all the water stays back here, so we have a dam with built up water. Once the tide gets down, then you begin opening the gate, water flows out, a lot of water, just like a dam and a reservoir. It just happens every high tide. We dam the water, we let it flow out, and you time it so the water flows all until it's out, high tide builds. So, every couple of times a day, you generate electricity from the bay. We're just taking advantage of the tide. Works really well, except you have to have a pretty unique type of setting to do it. Very difficult to just build a bay, if you will. So there's only certain areas that have the landscape, if you will, to take advantage of this, and there's a lot of challenges with it. Number one, there's not many places that are actually built to be able to do that. Few suitable sites. It's high cost. You got to kind of build that dam all the way across, and we're building in salt water. Dams in fresh water is much less corrosive than salt water. Salt water is intensely corrosive, so any kind of metals tend to rust. Also, the salt builds up on it from drying off, so we wind up getting equipment damage just from regular wear and tear, not to mention storms, right? Anytime you get a hurricane, any kind of big heavy storm, we get damage to the materials. So it's something that we know how to do, we're using, but it has its limits. Another is just taking advantage where the waves come in, that we can put things under the water, taking advantage of this as well. Lots of avenues that we're looking for offshore types of activities, but once again, anything that we're doing in the ocean comes with the added risk of the saltwater corrosion. It tends to corrode things much quicker, and storm damage. Guys, that's pretty much it for hydropower. Fairly straightforward stuff. Come back next time and we're going to look at the future of hydrogen power.